So we're now recording. Thank you, Paul.
No worries. Hello, thank you for inviting me and Richard here at Manchester to provide this presentation overview of a conceptual artificial intelligence framework for major infrastructure projects. This is a result of 3 MSc dissertations, and other projects which are going on in AI has also informed a lot of this as well, which you probably see some links to as I go through. So it's myself, Richard, and big thank you to the people who did the work, actually. So it's Minglei Chen, Maria Andawula, and Jinshan Wong. They were the 3 students who worked diligently on this project. Excellent guys. So thank you, chaps. And so just the contents, start with the main results. And for this AI framework, which is a kind of broad term for most things nowadays, but we focused on cost drivers from 2 key perspectives, at the estimating stages and the project delivery stages. We looked at how AI is used in major projects in the academic literature at the moment in cost estimating. So that's the first chunk, the first building block of the framework. The second one was a neural network demonstrator on some major project data, and we'll see why that was as the next building block. And then there's a cost estimating assurance checklist as the other building block, and a bit of a bonus, some view on generative AI, which is ongoing here at the university. So in the style of Red Indian storytelling, we'll start with the end and then explain why this is the end point. But we focused on the intersection of estimating, cost estimating, and major infrastructure projects because to use cost estimating in AI, there should be a new cost modeling data collection requirement. I think cost data is clearly extremely difficult to come by, is problematic in terms of collecting it into any sort of volume, and at different levels, critically at different levels of any work breakdown structure, can be expensive and inconsistent. So why are we doing this? To inform future data collection to enable this in the future, because I think currently it's difficult in terms of data. We are drawing a distinction here between cost drivers at the estimated stage and cost drivers at project delivery stages, and we'll see what we found these to be. But that's because to explain cost overrun, you really need to talk about project delivery cost drivers as being different to estimating cost drivers. That's something new. And there's a clear difference between academic novelty and practitioner novelty in AI. Lots of whiz bangs going on in academia, but a simple neural network is a sensible starting point for building capabilities. We did do that, and we found there's not enough data, and there's a bootstrapping method. We applied a resampling method to build the data up. And the other main result was that cost assurance, you need a proper cost assurance technique. So we developed a set of questions which includes this explainability approach for AI. So explainability has been around as long as AI, and is the AI topic area of how to explain these black box models, for instance. So these results are therefore, in terms of estimating stage cost drivers, 3 of the most frequent in the literature sample we took were project size in terms of the engineering, the contract amount, and the project delivery mechanism, because there was lots of different types of projects going on, from highways to utilities, different things. In contrast, project delivery stage cost drivers, the most frequent were the location of the project, the duration, and the complexity. As you can see, are different. In terms of prevalence of so-called AI methods, then neural networks and random forest regression are the most used in academic literature sample. We'll see what they are. In terms of neural network, sample sizes in UK public domain are minimal for cost modeling, and so we did a resampling method to try and improve that. And our AI cost assurance checklist areas emerging from a literature review of 38 papers were data quality, model validation, explainable AI, transparency, uncertainty and risk management, continuous improvement, and learning and ethical consideration. So those are the main thematic areas, and we got some specific questions in those areas. And the generative AI, well, at the moment, we're finding that careful prompt engineering is critical to get the right answer. Indeed, something called thought chain is required to structure estimating prompts in large language models because they are language models. It is possible to link data sources and create so-called custom GPTs. And recently, we've been trying to just generate coded bots. In other words, use something like Copilot to build Python programs to do the estimating task. So the generative AI is a tool to develop software, which is different. So it's no longer linked to the generative AI. So they're the main results at the moment. A nod to the University of Manchester, where we are, where at the moment celebrated 75 years of the Turing test. Like so. So in 1950, Alan Turing posed the question, can machines think? So as far back as 1950, which means in terms of this work, you've got to think about definitions. So when people talk about AI, it's an expansive field. And so, for example, Poole talk about computational agents, for instance, which is a type of or a concept in AI. However, machine learning, is the neural network type stuff, and they use these learning algorithms called gradient descent, a bit like nonlinear regression in principle, and of course the Turing test. So whether a computer passes the test of being artificially intelligent or not. So there's a whole range of things, and I think we're looking mainly at machine learning, but there is the generative AI development of agents as well, which I've also included in the results. So there's the three parts of the plus the generative AI, but the three parts of the conceptual framework being the drivers on the right, the explainability and data assurance on the left, and the demonstrator artificial neural network at the top there. So all intersecting has been important. So how have we made these decisions? What's the basis of this? Well, there is a rationale because the document top left there is the Data Analytics and AI in Government Project Delivery Corporate Report, which talks about exploring AI as a good thing to do. So that's what we've done, and we've used systematic literature review methods. We've used cost model development processes. We've interviewed practitioners in estimating in major projects. Sirish Parekh at UK, head of estimating UK Gov, NISTA, was kind enough to be interviewed on several occasions to steer this work. And we did some qualitative validation in terms of asking questions of how relevant this framework was to the literature as well. So we did there's a basis, a rationale, a methodology to what we do. So a lot of this is based around literature. We use this Prisma method to select, filter available literature through keywords. So just a nod to the Prisma method, the systematic literature review, which you can see there. I will not explain any of that, but there is a process to selecting the literature through keywords. So we found from 18 journal papers selected carefully, we found there's a range of size of data sets out there in major projects. On the right, you can see a pie chart. You can see a pie chart on the right, which gives you some sort of an indicator in the academic research literature of the amount of data being processed with some of these methods. Interesting there is 1,000 plus, which is perhaps the 11%. The 50 to 100 and the 100 to 500 kind of dominate in terms of data points. Of course, the more data you have, the more homogeneous it is, the better. But you know, projects are projects, and there's a degree of heterogeneity in all project data. So you can see there's a range there. At the top, 741 Florida transportation projects, for instance, or you've got the S9, the 57 road sections data, for instance, or S8, 11 construction projects. And you can see that we've drawn a distinction, or Jin Shan Wong did, between training and test, or training, validation, and test. So this is the peculiarity of machine learning models, is that you must train on some data and test and validate on other data. And there's ways of doing that. There's different ways of splitting the data set up, and maybe doing that several times over. So that's an important point, because you can so-called overtrain on data. You know, you could pick a data set which you train on, which might not represent properly other data, because of the sheer complexity of projects. That is a concern in this area. So the next thing we did was look at estimating cost drivers from the same literature sample. And there's a whole load of drivers there. You can see on the right the papers they were in. So project size is frequency of 11 papers. But there's a lot of other things, like there's like number of tunnels, excavation amount, filling type, shoring type, and different things like that. So at the estimating stage, there's all these drivers which are identified within the literature, reporting as drivers. And you can see the most frequent is project size, as what you would kind of expect. I guess there is some sort of Pareto there. Inflation rate is the next most impactful one. Type of project mechanisms, a lot of that about the diversity of projects in these major project data sets. You know, they're doing different things in different ways. And market conditions, type of foundation. So there's quite a lot of different estimating drivers. Contract amount is an interesting one. Almost like a cost-to-cost driver, a cost-to-cost relationship there. If we then kind of contrast this with project delivery cost drivers, then you can see things looking a bit different, which is important, because you know, we're trying to explain cost overrun, and we're trying to use a different set of cost drivers. It could become difficult. So you can see there, again, the frequency is on the right. So location of the project and duration seem to dominate a lot. Project complexity is there, frequency of three journal papers. There's a variety of kind of time related, like schedule performance index, critical ratio, design speeds. For example, you know, you might start a project with the design incomplete. So that then becomes a project delivery cost driver. And I suppose the argument here is these should form part of AI data sets to enable the full life cycle to be considered in an AI model in the future. Because one of our main missions, aim, objectives is to consider future data collection to enable a new technique. So there we have the frequency chart for the project delivery cost drivers. The risk or uncertainty factor might include the percent complete. Right, so you can see there's a contrast there. So the other part of this work is to basically look at all those papers have something in common, and they're all using this AI catch-all term, but they're all using different types of AI modeling methods. I can see the frequency there. This bar chart is a whole load of. I suppose what you could mention is, if you compare this to regression analysis or statistics, you can see there's a whole diversity of algorithms which people could potentially use, and that's the academic research community. They will do this. They will just try lots of different things. So that explains that. But as you can see, if we put this on some sort of chart, then artificial neural networks are most frequently, probably because they're perhaps the most straightforward, or they were the first on the block as well. Then you got random forest regression and your classic model of linear regression. So a whole range there on the bottom, which have all sorts of strengths. There's convolutional neural network there on the right, which is used for pattern recognition. For instance, there's a fuzzy inference system, again, only one. There's a variety of quite complex algorithms out there. And you'll see later that maybe an argument is, how do you assess the quality of these things? Because in linear regression, you have a method for that. But all these algorithms, how do you say how good they are? Anyway, so we applied this kind of work to a department for transport, major projects, portfolio data, and looked at what would be the impact on this data set. And if you look there at the bottom, then the potential to expand the data set by considering our findings is such that you can add more specific project categories and project size parameters, classify each cost driver into different lifecycle stages, like this project delivery, consider changes in the marketplace and the environment to include relevant economic indicators, such as the inflation and gross domestic products at the time of project implementation. And for the project delivery, you could add location and a measure of project complexity. So there is some potential for expanding the data collection in terms of major projects, portfolio data in the future. There must be, I guess, a trade-off for that, but there is that potential. So because we saw before, simple neural networks are probably the most popular and most maybe accessible to build capability in an area where there isn't much capability in terms of estimating. Then we went for a simple neural network, and so we found that there wasn't much data. I'm not going to spend too much time on this part because this is involved modeling. But as you can see, we found some major projects, portfolio data, and we did some of our own subjective judgment and created a further cost breakdown into that data set. See, there's HS2 phase 1 at number 8, Midlands Rail Hub. We did our own analysis for that based on literature. So we worked out that there were other cost driving factors other than the total cost, and we tried to include them into the data set using our subjectivity, and therefore give it some sort of cost breakdown. So get some more granularity into this data set, as you can see there, and then run a neural network in MATLAB. And a few features there, you've got the training, validation, and test data set, and you've got some mean squared error. You've got the R statistic, and so on. So what we did, we used this data augmentation. So we resampled the data to make it into lots of data points. So we randomly sampled from that limited data set to just create more and more data to enable the neural network, and also did some sensitivity analysis to work out which were the most significant cost driving factors. So that was done to demonstrate that neural networks have a capability in how they work, and there's a clear implication for data there. That we use this resampling method. So we use this resampling method because there was just a clear lack of data, and that would I mean, that would really stump any other method as well, any other type of cost modeling method, garbage in, garbage out. You can't work with small data sets and expect any sort of quality response. So you must synthesize this like human in the loop, as it were, keep human beings involved in the decision making and other things, which maybe leads us on to the other part of the conceptual framework, which was a cost assurance questioning method, which was developed from the literature. So after considering some of the guidance out there, like at the time, the IPA guidance, the Aqua book, the cost estimating and assessment guide, GAO, in the States, which has really got a really good way of presenting estimates and cost assurance, but also this ethics guidelines for so-called trustworthy AI. So that's from a general perspective. What is trustworthy AI? That's the catch-all. And there are a number of requirements for that. I could break my screen and show them. I've got the document, but we decided we wanted a more focused cost assurance for cost estimating, and so using this systematic literature review selection method, we identified 38 journals and come up with these thematic areas. So we need, from the analysis of the AIs, this is all AI literature. So from that analysis, the emergent areas are data quality, model validation. This explainable AI is really unique to AI, so that's important. Transparency, uncertainty and risk, continuous improvement, learning, and ethical. So this is our assurance checklist, and from the analysis of the AI journal papers selected, then there's a set of questions developed, as you can see here. So, for example, the cost factors identification, because projects are so complex, and maybe it's not possible to select all the important cost factors. But something neural networks pride themselves on is being able to select many inputs all at the same time. And that's a peculiarity of big data sets, where you could have potentially lots and lots of parameters, but then there is a problem of considering lots and lots of parameters as well. And yeah, so sometimes there are some statistical methods to shrink some of those closer to zero, the whole lot close to zero, to find out which one's the most important. Your so-called shrinkage methods. But anyway, so the cost factors identification. Yeah, so what method the model used to identify cost factors, for instance, or data accuracy? How is data accuracy verified before feeding it into the AI model? And on the right, there's some of the issues which are identified during the analysis leading to these questions. So things like missing data, overfitting, which we saw before, where because these models are very non-linear, you can fit a model too much to the data you train it on. It's too sensitive to the data it's being trained on. So when it tries to generalize to a test data set, it could be overfit onto the training data. For instance, you've got this incompleteness. Is there a comprehensive understanding of the cost factors involved in the AI model? So we have this data quality area. Then we have model validation. So we developed some specific questions there. For example, are there established benchmarks in the benchmarking? Are there established benchmarks or baselines used to compare AI model outputs? So are you, say, comparing things relative to other conventional estimation methods or other AI models, like a whole range of them? It is possible to use a range of different methods on the one data set and to say, okay, what does that mean? So that's a specific benchmarking question. And these test scenarios. So edge cases. Are diverse test scenarios, including edge cases, used to validate the model's performance because of the heterogeneous nature of major projects? The next one is the explainability one. And there's also this model interpretability. So there is a distinction between these terms. The one is the looking at specific nodes in a neural network, for instance, and saying what impact is this having. Another one is looking at the wider cause and effect parts of the model. So explainability has a number of techniques, and I've picked one, which is so-called model agnostic. So this LIME model, local interpretable model agnostic explanations. Before now, I have tried to put a cost model into generative AI and say, explain this, or let's generate an AI chatbot, an AI bot, and say, how does this work? Sort of question. But that's still early stages of research and trying to work out what that means. But LIME is basically you get your neural network or model and basically perturb it. So we'll put some inputs in around a particular area. So around a very localized range. So particular weight range or a particular project complexity range, or choose a small range for your cost drivers, and then generate some data from that, and then draw a line of best fit through it to look at, okay, in this part of the model, then a line of best fit is looking like this. So you can do that in all different areas of the model to just get like a set of local linear models to give you some sort of visualization of what's happening, because these things could be expansive non-linearities. So if you choose different parts, small ranges in the model, generate some data, and basically draw a line through it and say, okay, it's looking like that in this part, it's looking like that over there, it's looking like that over there. So it's just like drawing a graph, just by interrogating the model in local parts, in small parts of the model. So that's an interesting method which is widely applicable. And with this explainability, are there any black box components of the model that need further explanation? Because of the prevalence of this black box nature of AI and machine learning, then that's an important question to consider. So hopefully these questions are making, I guess, some sort of sense. These are reasonable questions. They are the emergence of analysis of 38 papers. So hopefully they are okay. So, but there is further work to validate these as time goes on, as work progresses. Then we've got the transparency side. So like model development documentation. Is there thorough documentation of the AI model's development, including design decisions and assumptions? How transparent is the process for updating or modifying the model? So is it fully explained? What steps you take in terms of its development and then its use and test. That's really important, because sometimes you just get a model and you have to try and pick your way through it. So you need a full journey, a repeatable journey of the model development, which is more involved in AI than other areas. So the current parametric cost model development process really needs to expand. We look at the NASA guidance and the historical ISPA, Institute Society of Parametric Analysts, which are now part of IKEA, I guess. But they had a really good document in terms of parametric cost model development process. I think there's a clear requirement once these methods become serious or demonstrate usability to have something similar in terms of being transparent. And that goes on to say data and model governance. Are there clear governance practices for how data is selected, used, and maintained within the model? So, clear governance. Who is responsible for overseeing the ethical use and performance of the AI model? Where in the organization should that sit, actually? Because that's that's a significant disruption. And you can ask the question, you know, what is the cost engineer of 2030? What do they look like? What does the organization look like in terms of that? So, and then we move on to uncertainty and risk as another key thematic area. And you can see there are more questions there which have emerged. I think one thing we can say here is that if you're a parametric analyst, then you're probably used to considering confidence intervals. Whereas with these machine learning models, neural networks, people don't routinely talk about that, which I find quite surprising. But there are methods out there to develop confidence intervals, just like parametrics. And you basically use the same assumptions as you do in parametrics in terms of these assumptions of normality. But you use the same assumptions as parametrics, and you are able to develop these confidence intervals like that. Or there's this resampling method where you could use bootstrapping to do that. So one improvement which people should do, I think, is start to routinely develop confidence intervals for visualization. So there's at least line, which we saw earlier, and also confidence intervals will start to give us some insight into these machine learning methods, some more insight based on the fact that data can be a little bit impenetrable at scale. And also if you're trying to audit a model from a standing start. As well as now the generative AI, which is becoming increasingly useful, perhaps, in assessing inputs, given the ethical constraints we have. You know, as cost engineers, we need to be really careful with generative AI and giving anything to it because of its, you know, the ethics and copyright and commercial data. It's just a completely new risk which has just emerged from nowhere. In terms of giving cost data, you should never give cost data to generative AI, unless, well, probably never. I don't know. You know, there's an argument for just using your own local models, but so in terms of continuous improvement, then we have some more questions there. Maybe an important one there is feedback loops. Is there a mechanism for incorporating feedback from project outcomes back into the model? I think that's generally true of cost estimating anyway. And how is stakeholder feedback utilized to refine and improve the model? And then last but by no means not least is the ethical considerations. So we're looking for things like bias, underrepresented project types. And this happens also in parametrics. You could choose or bias things just by your selection of data. It's just not just outliers. You know, even in the data set itself, it could be a major impact. Some of the data can have major impacts on the outcome. So it's recognizing that and asking questions about it, and also ensure fairness and equity across different project stakeholders. And maybe this starts to go into the trustworthiness of AI now, which is the wider AI assurance. So, I'd say, like in the style of the Red Indians, then our main results that we started with, but this is a reiteration. So now you can see that there is an intersection between estimating and AI, and there is a new challenge for data collection going into the future. And I guess if that challenge is met, it perhaps opens more doors to potential value adding. So in time, there must be at least a plan to think, you know, to start to collect, to change data collection, to enable more capability. We've seen these different types of cost drivers, like estimating a project delivery, and why that's important in terms of looking at cost overrun. You've seen the range of academic level machine learning AI models, and even a simple neural network you can see is data hungry. So maybe resampling is one technical way of building up data, which we have in MATLAB. But that's that's the statistics type solution, which you see in other areas of stats. And now we have some proposed cost assurance questions emerging from analysis of AI journals and cost. And explainability is a topic area of AI which intersects with that. And we've seen that there's some major estimating cost drivers or project delivery cost drivers, project size, contract amount, and project delivery as different from location, duration, and complexity to explain cost overrun. And the artificial neural network, we saw the data could be broken down more, and there could be more of it to enable that. And there should be some sort of detailed AI cost assurance checklist to start to dig into the issues. What are the issues in these AI models? And there's a wider AI, trustworthy AI. There's a wider part of that, which I don't know where in the organisation that will sit. But these are bigger questions, and this is just a subset of that. And we've seen that generative AI, which is something different, something else we've been considering. But from my experience, detailed thought chain and these areas like generating coded bots they're the things which have been the trajectory which has emerged from consideration of these of generative AI. But they are language models, so they're not number models, as it were. So you need to develop an agent or a software or a wider structure to enable calculations to be done more effectively. And where are we? I think that's nearly 45 minutes. And well, there's a conference next year, which we can talk about in a short while. So I guess time for questions.
Thank you, Paul. Very interesting. There have been some comments in the chat which Richard has been handling, I think, as you've been talking, which has also been very useful. I think there's probably one question, and Richard, correct me, that you didn't necessarily tackle, which was right at the top from Val, which said, what reliability do you have on the data collected? If you have enough information spanning over years, you can get more it's a statement, sorry. You can get more certainty around trends and, more importantly, exclude outliers from data collected schemes. So I think that was a sort of half question, half statement.
I'm happy to answer, happy to give a response if it's helpful. Yeah, so it's a very good point. And the way in which the government major projects portfolio data is collected is an ongoing challenge. The ways in which the delivery confidence of government projects is assessed has also recently changed to a arguably more simpler RAG rating system. But the quality of the data that the Infrastructure and Projects Authority, now NISTA, collect has to spare with me 1 second. It does require a degree of kind of assurance within government departments to make sure that it's of the best quality. We also kind of know that resets in government projects or changes in the strategic outline business case or outline business case can also have an effect on costs. And of course, you will have seen with things like High Speed 2 and other major projects that are to some extent at the behest of political, I won't say interference because that's not the right word, but political change and such like can also have quite a big impact on machine learning models.
Okay, thank you. I don't think there is anything else in the chat that hasn't already, as you said, Richard, already been answered or commented against, which is really helpful. Thank you. I don't know if anybody else has got any questions that they can put in the chat, or I think you can react with sort of a hands up notification, and I can see that. But as well, if you have got anything or want to add anything, I would just say on the last slide that Paul shared, it is about the Controls and Skills Authority conference next May, which is, oh, thanks, Paul, which is happening at etc. venue again in Manchester. So the same place as we've been for the last couple of years. Tickets are actually available for you to purchase to attend. Prices are very reasonable. Students and retirees have been kept the same as last year. Members and non-members have gone up slightly, but not inconsiderable at all. Membership ticket prices are very, very reasonable compared to all other events. There are sponsorship available, opportunities available to have a stand. Call for papers. We are looking for speakers. We've got a number of people who have already come forward, but obviously open for all people to suggest and talk at the conference against the themes of control, skills and authority. And then I'm going to say next year, because it is next calendar year, but the next conference, we are holding our awards evening on the night of the 13th of May at a bar in Manchester. We will have an Oasis band playing. Our awards are up for nominations. We've got 8 awards that you can nominate for. Do have a look at the wide variety of awards that are there, covering all levels of experience, as well as sustainability, digital, and the sort of standard projects that you've participated in. So I would strongly urge you to look at the website for more information. And with regards to, thanks, Val, for confirming your part of NISTA, that's great. And with regards to those of you that are members that didn't hear me at the beginning, your CPD points for attending today will be uploaded against this webinar once we've concluded. And those people listening on record back, can you upload your own? Because I won't know that you've listened to it unless you do it yourselves, but CPD points are available against this. I think one CPD point, as that equates to 1 hour. I'm conscious that we are sort of 20 past just gone, or just about approaching 20 past 1. If there is nothing else that either Paul or Richard want to add, and no one else has put anything into the chat, I will call it a day and we'll get some time back on our lunch. But thank you all. Les, Paul, Richard, you did want to say something before I say final thank you.
Nothing more from me, but thank you for everybody's attention, and very happy to take any follow-ups after today's seminar.
Lovely, thank you, Richard. Paul?
Yep, it's okay. Yeah. Happy to. Thank you for the opportunity.
No problem. Well, thank you all to everybody, and hope to speak to many of you soon, and hopefully see you at our conference next May. And this will be available once I've worked out the technology aspects of it. This will be available as soon as I can, and have a lovely rest of your days.